I'm Pallavi, your host for today's session. Let me give you a brief introduction about who we are. Protrainy is an NSR cell, Bangalore pre-incubated EdTech startup. We are registered with Startup India, Startup Odisha, and OCA. Landing skill requisite which precisely fit market demand is tougher than landing a job itself. That's where we come into play. We prepare engineering students to be industry ready by training them for the essentials required in the field. We believe that skill building is an extensive process which requires detailed and practical knowledge with the help of our experienced expert. Our only aim is to build a skilled workforce for the civil engineer industry and to create thought leaders of tomorrow. Protrainy brings to you an evolving industry-ready environment to tackle the ever-shifting business scenario. As an educational platform creator, we upskill civil engineers in technical domain as per current industry trends. From theoretical concepts like structural engineering, bridge engineering, to software trainings like Oracle Primavera, eChabs, AutoCAD, we offer 360-degree holistic development required for a civil engineer to become a skilled industry professional. We recently conducted an industry-ready long courses on tendering, building, Primavera, highway engineering, etc. And good results in this scenario has motivated us to go beyond our boundaries and get more for all of you. To be updated with our upcoming amazing courses, go and follow our Instagram, Facebook, and LinkedIn profile by the name Protrainy. Now, I would like to introduce our expert, Ms. Arapika ma'am, who have joined our forces to make everyone industry ready. We welcome you, ma'am. I now request ma'am to start with the session. Thank you. Over to you, ma'am.
Thank you. Hi, good morning, one and all. Is it audible? Hello. Hello.
Yes, ma'am, you are audible as everyone is on mute.
Okay, thank you. I am Swati. I have 5 years experience in the civil field in the planning and designing field. Actually, we have the more opportunities in the site as per the construction field, like a residential irrigation field, like that. First of all, know about the what is the planning, what is the irrigation schemes, and how to planning and design. Okay, can I start? First of all, my intention is the how to planning and how to use for the irrigation field. Okay. First of all, irrigation scheme. To explain the concept of the irrigation scheme and its concept and impact on the construction industry, to help the educate students and understand the what is life cycle and how to design, how to plan, and how to implement. Okay. First of all, in this session, what are the covering? Introduction, what is irrigation, types of irrigation, importance of irrigation, and principal features of the proposed scheme. Finalization of CCA. CCA is the command chalk area. Okay, and chalk planning. Alignment planning. Next topic, pipe material. Which material we are using? Is it HDP or DI or at MS? Okay. Next thing, velocity. How to consider the velocity and pressure diameters, the pressure and diameters, design criteria. Almost all know the Ethernet software. And
excuse me, ma'am. Sorry to interrupt. Are
Hello?
you sharing your screen? Are you sharing any slide?
Yeah, sharing.
It's not visible, ma'am. Can you please reshare it?
Okay, okay. Is it visible? Hello?
Yes, ma'am. It's visible.
Okay, okay. First topic is the introduction. What is irrigation? Water is an essential part of the for the survival for every human body. Okay. Is it disconnected? Just wait. Okay. Hello.
Yes, ma'am. It's visible now.
Okay, okay. Just wait a moment. Okay, can I continue? Okay.
Yes, ma'am. You can continue.
Okay. Water is an essential element of the for every survival, and human body consists of the 70% water, and plants also consist of the 90% water. Okay, depend on the outside sources, we fulfill the water requirements for our body and also our crops also. Similarly, crops require more water. In this situation, summer have a more, summer have a less water, depending on the crops and the growth and development. The process of supplying water to the crops is known as the irrigation. What is irrigation? Irrigation is the process of applying water to the crops artificial to fulfill their water requirements and give the nutrients to the provided to the crops by the supply of the irrigation. Various sources of the water irrigation like natural sources like ponds, lakes, canals, tubes, even dams also. Artificial sources, the dams. Irrigation offers moisture required to the growth of the crop and development, germination, and other related functions. The frequency of the rate and amount time, these are the three factors important for the irrigation. Okay, types and also these are the depend on the type of soil and seasons. For example, For example, summer crops requires a higher amount of water as compared to the winter crops. Types of irrigation. Next topic is the types of irrigation. Different types of available. Surface irrigation, localized irrigation like pond, lakes. These are the localized irrigation. Sprinkler irrigation, drip irrigation, central pivot irrigation, sub-irrigation, manual irrigation. These are the two methods. Importance of irrigation. Why are you using the irrigation field and how to what is the basic importance? Insufficient and uncertain rainfall adversely affect the agriculture. That means the droughts and famines are caused due to the lower rainfall. Irrigation helps to increase the productivity, even low rainfall. That means the wherever the less rainfall, there also increase the productivity. How to increase the productivity? By supplying the artificial methods to irrigate the supply of water. Okay. The productivity on irrigated land is higher as compared to the unirrigated land. Next thing, multiple cropping is not possible in India because the rainy season is specific in most of the regions. However, the climatic supports cultivation throughout the year. Okay. Irrigation facilities makes it possible to grow more than one crop in most of the areas and of the country. Irrigation increases the availability of water supply, which is in turn to increase the income of farmers. Next topic is the general layout and principal features of the proposed scheme. Okay. First of all, general layout. How to create the layout and how to construct. First of all, to lifting the water, first of all, to construct pump house. Okay. Then the pump house, after that, we construct intake well, some to main lines to distribution to sub, like that. Okay. First of all, to take the approval for any government project, first of all, we study the preliminary survey. How to first to know the project details, how much area and how to cultivate, like that, which crops are grown in that area. After that, we prepare the detailed survey. Detailed survey in this, the first consists of the BCL plan, broad chalk comment map to take the approval, rough estimation to some how much area irrigate to it will be 1 lakh I cut, 2 lakh I cut. They will decide. Okay, first topic is the intake structure. Intake structure will be located in the main stream of the river, so as to get the water supply during the Kharif season. Whenever surface water is at the rivers is available. That means that wherever the rivers that the source is used for the Kharif season. The water level considered for intake is the lowest water level at the end of the Kharif season. Okay, next topic. The intake well with the fixed with trash tank to connected to proposed pipeline. Okay. proposed pipeline conveying water from the river to some pump house. Okay. Trash tag. The removable trash tag. The removable trash tag is provided two places for the filtration, coarse and fine material as per tender. That means from the river to the fine materials, that the coarse or fine materials, that the only it is used for the filtering process. Next, connecting pipeline. Connecting pipeline, that means the some to water distribution purpose connecting pipeline is used. This means in this the length of the connecting pipe should be shown in the GAD and L section should be provided. That means the L section means longitudinal section. Longitudinal section, so what purpose it is used to know the how much ground level and top level, top of the pipe level, next bottom level, next a gradient line. This purpose L section should give the brief description. Okay, sump and pump house. Where will construct sump house and pump house? Sump house and pump house will be construction near to the left bank of the Frictional river. Or wherever, for example, I am giving the Frictional river. Okay, taking into the consideration the high flood level at the location. Wherever the high flood level, the sample is to constructed. Okay, as well as the electrical and pump and control room will be located along with the pump house. Next topic, finalization of the CCA. Chalk command area. These are the most important features for the any irrigation planning and chalk planning and CCA. And also water supply schemes also, these features are the most important. First of all, the detailed survey and collecting the revenue records from the department and site. First of site and the cultural command area under the scheme was identified by deducting the by deducting the uncultivated land. That means the uncultivated means government land or pond, lakes, what is unsurveyed. These lands are the uncultivated lands. Okay, gochar lands and village settlements. Village settlements is where there is number of houses, there will be no cultivated land. That is the uncultivated land. Okay, what are the guidelines for the chalk planning? As far as possible, chalks are considered for the available natural topographical boundaries. That means the major nalas, roads, village settlement areas, survey boundaries, hills. These are the excluded. That means they should not cross the distribution pipes. While planning the chalks, should not cross the village boundaries also. That means the two villages like A, B. There are the two villages should not cross the aligned chalk. One village it will be, we consider 20 hectare chalk. Last moment 10 hectares from A, 10 hectares from B should not draw. As far as possible, average chalk area is close to 4 hectares. Depending on the agreement or BOQ, as per the DPR, they should mention to take the 4 hectare chalks, 20 hectare chalk, 10 hectare chalk. Every project depends on the that 20 to 40 hectare chalk. Then divide to 4 hectares or like 2.5 or 1 hectare, depending on the project. However, the CCA for each chalk will be varying due to the natural topographical features. What is the chalk? Chalk is the which area is cultivated is called a chalk. That means there are the number of topographical numbers. That means 1, 2 survey numbers. These are called survey numbers. Survey numbers should connect the 4 survey numbers to should prepare the some chalk like that. The chalk planning is done in such a way that as far as possible, proposed outlets should prepare the outlet should be prepared at the highest location. Okay. The chalk size should be average for the 4 hectares. For example, to take the 4 hectare chalk, to draw the chalk for the 20%. We cannot draw the chalk at least for every chalk 4 hectares means cannot draw the 4 hectares. In such a case, should correct the 20% exemption. That means the 3.2 to 4.8. Like the drum. Alignments. What is alignments? Alignments is the pipe connection from some to distribute the pipes from MS to DI to HDPE like that. Main lines mostly use the MS and DI, and field pipes smaller dia pipes that the HDPE mostly use. Okay, alignment of the distribution network line should not cross the roads, railways, ponds, uncultivated lands. Should not cross. For example, there is the more houses. These are the uncultivated land. Should not lay the on the top houses, along the houses. There will be no government will agree. They didn't agree. So that's why eliminate. The apex points are coming in horizontal alignment so as to avoid obstructions such as village settlement areas, forest, land, nalas, roads, hills. What are the obstructions should avoid? Okay, the distribution network is aligned such a way. What should irrigate the chalks? By using the HGL. HGL means hydraulic gradient line. Should always be top of the alignment. The diameter of the distribution network lines are varying from head to tail portions. That means wherever we provide the 500, again should provide the 500 or 450 like that, but should not provide the 600. That means a head to tail. The direct outlets on distributors are proposed to provide irrigation to adjoining chalks and branches. That's why you use it to adjacent chalks to main lines to distribution lines. Like that provided. The branch lines are provided to the last chalk in the command area. That means the main line should be provided along the throughout last village, and also branch line should be provided along the last command area, and that means last command chalk. All the pipelines of distribution network will be laid below the minimum depth of soil. That means the overburden, called as the overburden. Overburden should be provided at least 1.2 meters from the ground to top of the pipe. Cover walls will be provided at the suitable location for the down areas. That means the valley ponds, wherever the valley ponds and down areas provided, where that the cover walls will be provided. Air walls where we provide, air walls will be provided for the top of the, that means the highest highest elevation of the eye cut along the pipeline. Okay, what the materials we used for the pipes? Which material we used? These are the considerations basically depend on the DPR. There will be given the DPR project records. There will be clear records on clear records. There will be given, that is the which materials are available and which type of pipes are available. How much pressure considered? How much diameter used? Next considerations. What we consider, these are the most are available in the DPR. Okay, first of all, for example, 1000 to 600 up to 600 mostly used called as DI. Okay, after that DI. Up to 600 ms, 600 to below 3 up to 350 DI. Next, DI means ductile iron, ms main steel. Last of all, HDPE. After that 350, there will be used only HDPE. No, it is CI, cast iron. These are not used for the irrigation field, because of the more rust due to the water. More codes are available. DA for the code is IS L3292-2000, and also HTTP also some grade code IS 4984-19984. Okay, minimum dia of the pipe. Every project have a minimum dia of the project 75 mm. HTTP is used. Okay, next content is the velocity. How much up to velocity we used? What consideration? First of all, velocity, how to decide? These are the depend on the EPNet software. Okay, EPNet is the internal continuity mass balance energy. That means the including in the software, they are used to take the including frictional loss and pumping energy. These two equations are solves the mass balance equation throughout the distribution. Okay, most of the cases consideration minimum velocity for the irrigation process 0.6 meter per second. Maximum permissible velocity 2 meter per second. These are the most useful features. Diameter. Next topic is the diameter. Based on the above criteria, we have selected the pipeline, which means the what we use is for MS or DA. We can choose. That means the MS means where we provide MS. Where can velocity will be 2 meters, up to 2 meters. There will be the we use MS 1.22 to 2. Okay, below 1.2 DA 0.82 to HDP. Okay, minimum residual head depends on the project. 15 meters consideration. These are the features are given in the DPR. How much considered? There we provide the decide to diameter of pipe. Okay. As per the above mentioned methodology and guidelines, the detailed layout and hydraulic design system should be prepared showing chalk boundaries and each CCA of each chalk. CCA means deducting the uncultivated land from the cultivated land. There we will decide the I cut. Next one, location of outlet. Location of outlet for each chalk. Where we provide the outlet, highest elevation of the element. Alignments of the distribution network along with the nomenclature should give the nomenclature. There will be one, we decide the LBC 1 like that, sub-mine 1, sub-mine 2, sub-mine 3, like that, give the some names depending on the project title to. Node numbers. Again that we prepared the node numbers. Depending and compared to the chalk command map and also EPNet, there will be same node numbers. Pipelines between the nodes and discharge between the nodes and diameter between the nodes. These are the most important features. Design criteria and consideration. What are the guidelines we follow? For selecting the diameter in a sorry. Yeah. Selecting the guidelines, we minimize the diameters for economical way to choose the diameter and limiting the velocity and head available from the HGL, hydraulic gradient line. After that, considering the frictional losses in the pipe. Almost frictional losses considered as the 5 meters, 7 meters, like that. Hello? Okay. Head available for the design will be head difference between the HL starting point to ending point. That is the minimum 15 meters we consider. Okay, next point is the HL will always be above the ground level. Should is the gradient like that. In the how to decide the is it gradient or like that, to where we know is it the longitudinal section to decide the is it whether it is the gradient or not. These are the depending on the longitudinal section to know. There will be no more losses, such as losses like that. Also, there will be most of the cases considered. After that, the outlet point in each chalk should be provided the highest elevation of the chalk. First of all, these are the which cases are considered for the chalk planning. Chalk planning, in the chalk planning, what we considered in the chalk planning should be avoid the uncultivated lands, like that the chalks, like that the ponds, nalas, rivers should be almost every time should avoid and should not cross the alignment along the pipes, through along the roads, rivers, major streams, like that. These are the most consideration point. Already told that minimum velocity, minimum residual head should be provided 15 meters as per the DPR. Velocity should be provided 2 meters. Minimum velocity should be 0.6 meters. Okay. Frictional losses in the pipe. How to calculate frictional losses? Frictional loss, you know the Huygens-Williams formula. There will be we calculating the head loss. HF equal to 10.75 L into Q by C power 1.852 by D power 4.87. HF means loss due to the friction in meters. Q will be discharge in Qmax. That means the meter cube per second. L means length of the rising main in meters. C means the Huygens-Williams toughness coefficient. Should be always takes for the 140 and 130 only for the E-pennet. D equal to internal diameter in meters. We discuss about the E-pennet software, where we use and how to use. E-pennet software is used for the distribution and irrigation projects, mostly to decide the pressure and velocity to design in economical way to used for the E-pennet software. E-pennet software is the first of all from the drawing to AutoCAD drawing to we convert the DXF file like that. DXF file to convert the AutoCAD. AutoCAD DXF converter also available. DXF converter to take the all pipelines in converted into DXF. DXF to we draw the E-pennet software, E-pennet file. Okay. E-pennet file should be available in the .NET. Okay. And in the E-pennet, no limit for the sizes of pipes depending on the velocity and pressure to decide the diameter. So no use for the limited diameter 75 or like 63, not like that. Should provide with every project depend on the velocity and pressure head. Okay, next minor losses due to the bends and fittings also considered. And also air walls, these are also where we provide also to know the E-pennet software. Operation program is very simple and installation also that is that means the nodal pressure and flows in each pipe easily understand. What are the inputs and outputs? After that, input the data alignments in the .NET file. Again, first of all, we fix the node numbers. Again, that give the input for the elevation for every node. After that, input. After that, we give the elevation at the tank and pumps also. After that, we give the diameter based on the velocity and discharge. These are the common features in the input features. What are the output features is available? Flow in each pipe at velocities also to know the next thing. Pressures also know. Next ground level and hydraulic gradient line. Pressure contours. Shorting out the pressures and diameters and elevations, etc. Flow direction also important. After that, next section, we should know the how to use the input and how to draw the chalks. Everything we know the next topic. Okay. Thank you. Hello.
Thank you, ma'am, for the session. It was like
Any
really
questions?
informative. Students can fill the I'll let the students unmute them. If you have any questions, you can unmute yourselves or you can post in the chat box. Ma'am, I guess one student is asking for useful section.
Okay, thank you. If there is any section after that, how to prepare charts and how to implement. Actually, I have the laptop issue also. I am using my husband's laptop, so it is the company laptop. So I am not giving the any PDF like that. Drawings like this project is my personal project.
Okay, ma'am, no issues. And that PPT is enough for the presentation.
Okay, thank you.
Thank you, ma'am. Students can fill the Google form for the certificate, and I'll end the session now. Thank you, ma'am.
Thank you. Hello.
Yes, ma'am.
One person is raising the hand. What is
Yeah,
that?
I had texted him. He didn't say anything. Like, I don't know why is he raising the hand.
Okay, okay. Boss is like that name.
Yeah, Bas. I texted him. He was not responding to my text.
Okay, thank you. I'm
Okay.
leaving. Okay.
Okay, ma'am. Okay. Okay.